When installing under-cabinet lights, also known as hockey puck lights, that operate at 12 volts using a 120 volts AC transformer, it's crucial to use the correct type of listed wire that is safe for in-wall installation. The following provides a breakdown of the necessary wire characteristics and some recommendations. Firstly, consider plenum-rated electrical wire. This is designed to be installed in plenum spaces, which are air-handling spaces, but can also be used within walls. Secondly, the conductors should be a minimum of two, one black and one white, with a gauge of either 18 AWG or 16 AWG. The wire must have a voltage rating of at least 120 volts AC, as this is the voltage supplied by the transformer. The temperature rating should be a minimum of 90 degrees Celsius, which is equivalent to 194 degrees Fahrenheit. It is important the wire also has either a CM or CMR communications and multipurpose rating, or a CL2 or CL3 Class 2/3 rating. This indicates that the wire is suitable for in-wall installation. It's important to ensure the wire is suitable for both dry and damp locations. Here are a few specific listed wire recommendations that meet these criteria. South wire and MB14/2 wire with a CM rating is one option. General cable 18/2 plenum wire with a CMR rating is another possibility. Monoprice plenum rated CL2/CL3 wire, which is AWM style 1015, is also a suitable choice. Now, let's discuss these wire characteristics in greater detail. Plenum rated cable is designed to minimize the spread of flames and smoke in the event of a fire. This is a critical safety feature when running wires within walls or in air-handling spaces. The conductors within the wire carry the electrical current. The black wire is typically the hot wire, while the white wire is the neutral wire. The AUG, or American wire gauge, indicates the wire's thickness. Lower AWG numbers indicate thicker wires, which can carry more current. For under-cabinet lighting, 18 AWG or 16 AWG is generally sufficient, but always check the specific requirements of the lighting fixture and transformer. The voltage rating indicates the maximum voltage that the wire can safely handle. Using a wire with an insufficient voltage rating can be dangerous and could lead to electrical shock or fire. The temperature rating indicates the maximum temperature that the wire can withstand. If the wire is exposed to temperatures exceeding its rating, the insulation can melt or degrade, leading to a short circuit or fire. The CM, CMR, CL2, and CL3 ratings indicate that the wire has been tested and certified for specific applications. CM-rated wire is suitable for general communications purposes. CMR-rated wire is suitable for riser applications where the wire runs vertically between floors. CL2 and CL3-rated wire are suitable for low-voltage applications, such as under-cabinet lighting. The suitability for dry or damp locations indicates the environments in which the wire can be safely used. Some wires are only suitable for dry locations, while others can be used in damp locations as well. When selecting a wire, it's important to choose one that is appropriate for the environment in which it will be installed. Let's further elaborate on the wire recommendations. South wire NMB14/2 wire is commonly used for residential wiring. It is a non-metallic sheath cable that is suitable for dry locations. The 14/2 designation indicates that the wire has two conductors plus a ground wire, while the provided link shows a 14/2 wire for under-cabinet lighting with a 120 volts to 12 volts transformer. A smaller gauge like 18 AWG or 16 AWG may be sufficient and easier to work with, depending on the current draw of the lights. General cable 18/2 plenum wire is specifically designed for plenum spaces. It has a Teflon insulation that is highly resistant to heat and chemicals. The 18/2 designation indicates that the wire has two 18 AWG conductors. Monoprice plenum rated CL2/CL3 wire is another option for plenum spaces. It is a low-voltage wire that is suitable for a variety of applications, including under-cabinet lighting. The CL2/CL3 rating indicates that the wire is certified for use in Class 2 and Class 3 circuits. Class 2 and Class 3 circuits are low voltage circuits that are considered to be relatively safe. Before commencing any electrical work, it's absolutely essential to consult with a qualified electrician. Electrical work can be dangerous, and it's important to ensure that it is done safely and in accordance with all applicable codes and regulations. An electrician can help you select the right wire for your specific application and can also ensure that the wiring is installed correctly. Here are some additional safety tips to keep in mind when working with electrical wiring. Always turn off the power to the circuit before working on any wires. Use insulated tools to prevent electrical shock. Wear safety glasses to protect your eyes. Follow all applicable codes and regulations. If you are not comfortable working with electrical wiring, hire a qualified electrician. It is important to consider the National Electrical Code, specifically Article 411, which covers lighting systems operating at 30 volts or less. Ensure that the wiring method complies with NEC requirements for low voltage lighting circuits. Also, pay attention to the ampacity of the wire, which is the maximum amount of current that the wire can safely carry. Use a wire size that is appropriate for the current draw of the lighting fixtures. The current draw can be calculated by dividing the wattage of the lights by the voltage. For example, if you have 10 watts lights operating at 12 volts, the current draw would be 10 watts divided by 12 volts, which is approximately 0.83 amps. Select a wire gauge that has an ampacity rating that is greater than 0.83 amps. When making wire connections, use appropriate connectors that are designed for the type of wire being used. Wire connectors should be properly sized and tightened to ensure secure connection. Loose connections can cause heat buildup and can lead to electrical fires. When running wires through walls, use grommets or bushings to protect the wire from abrasion. Abrasion can damage the insulation on the wire, which can lead to a short circuit or fire. Ensure that the wires are properly supported and secured to prevent them from sagging or becoming damaged. Wires can be supported using cable ties, staples, or other approved methods. Do not overload the circuit. Overloading a circuit can cause the circuit breaker to trip, or can even lead to an electrical fire. Ensure that the total current draw of all the devices on the circuit does not exceed the ampacity rating of the circuit breaker. When installing the transformer, follow the manufacturer's instructions carefully. The transformer should be installed in a location that is accessible for maintenance and repair. Ensure that the transformer is properly grounded to prevent electrical shock. Use a multimeter to test the voltage and current in the circuit. A multimeter can be used to verify that the voltage is correct and that the current is not exceeding the ampacity rating of the wire. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. Remember that electrical work can be dangerous and it's important to take all necessary precautions to ensure your safety and the safety of others. By following these guidelines and consulting with a qualified electrician, you can safely install under-cabinet lighting in your home. In addition to the wire recommendations provided earlier, consider the specific requirements of your local electrical codes. Local codes may have additional requirements for wiring installations, so it's important to be aware of these requirements before starting any work. Furthermore, it is important to note that while an MB wire can be used inside walls, it is typically used for standard 120 volts or 240 volt circuits. For low voltage under cabinet lighting, using CL2 or CL3 rated wire might be a more appropriate choice. The key is to ensure the wire is listed and rated for the intended use and that it complies with all applicable codes and regulations. When selecting wire, consider factors such as the length of the wire run. Longer wire runs will experience greater voltage drop, so it may be necessary to use a larger gauge wire to compensate for the voltage drop. Voltage drop can cause the lights to dim or flicker, so it's important to minimize voltage drop as much as possible. To calculate voltage drop, you can use online voltage drop calculators or consult with an electrician. It is crucial to consider the type of insulation on the wire. The insulation protects the wire from damage and prevents electrical shock. Different types of insulation have different properties such as heat resistance, chemical resistance, and abrasion resistance. Choose an insulation type that is appropriate for the environment in which the wire will be installed. For example, if the wire will be exposed to high temperatures, choose an insulation type that is heat resistant. Always inspect the wire carefully before installing it. Look for any signs of damage, such as cuts, abrasions, or discoloration. Do not use damaged wire as it could be unsafe. When stripping the insulation from the wire, use a wire stripper that is properly sized for the wire gauge. Using the wrong size wire stripper can damage the wire. Be careful not to nick the wire when stripping the insulation. Nicks can weaken the wire and can lead to breakage. When making wire connections, ensure that the wires are properly twisted together and that the connectors are securely fastened. Loose connections can cause heat buildup and can lead to electrical fires. When running wires through metal studs or other metal objects, use grommets or bushings to protect the wire from abrasion. Metal objects can chafe the wire and damage the insulation. When installing wires in conduit, use a wire lubricant to make it easier to pull the wire through the conduit. Wire lubricant can also help to protect the wire from damage. When working with electrical wiring, it's always better to be safe than sorry. If you are unsure about any aspect of the installation, consult with a qualified electrician. Remember that electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Before connecting the low voltage wiring to the 12 volts lights, ensure that the transformer is properly connected to the 120 volts AC power source. The transformer should be connected to a dedicated circuit breaker to prevent overloading the circuit. It is also essential to verify the polarity of the wiring. The positive wire from the transformer should be connected to the positive terminal on the lights, and the negative wire from the transformer should be connected to the negative terminal on the lights. Reversing the polarity can damage the lights or the transformer. After completing the wiring installation, test the lights to ensure that they are working properly. If the lights do not turn on, check the wiring connections and the transformer. If you are unable to resolve the problem, consult with a qualified electrician. In summary, selecting the appropriate listed wire for under-cabinet lighting involves considering several factors, including the voltage rating, temperature rating, insulation type, and compliance with applicable codes and regulations. Always consult with a qualified electrician before starting any electrical work and follow all necessary safety precautions to ensure safe and successful installation. Using the correct type of wire, making secure connections, and following all applicable codes and regulations will help to ensure that your under-cabinet lighting system is safe and reliable. Also ensure that the selected wire is compatible with the type of connectors being used. For example, some connectors are designed for use with solid wire, while others are designed for use with stranded wire. Using the wrong type of connector can result in a loose connection, which can cause heat build-up and can lead to electrical fires. Therefore, ensure the wire matches the type of connectors. In addition to using appropriate connectors, it is also important to use the correct tools for making wire connections. Crimping tools, wire strippers, and pliers should be properly sized and insulated to ensure a safe and reliable connection. Using the wrong tools can damage the wire or the connector, which can lead to a loose connection. Ensure to research the tools that are meant for the wire and connector types. Finally, before energizing the circuit, double-check all wiring connections to ensure that they are secure and that there are no exposed wires. Exposed wires can pose a shock hazard and can also cause a short circuit. Using a multimeter to test for continuity and voltage can help to identify any potential problems before energizing the circuit. Following these recommendations will help to ensure that the under-cabinet lighting installation is safe, reliable, and compliant with all applicable codes and regulations.